So what actually makes Mr Mannequin compatible? I've had an overwhelming amount of positive feedback over the past few days since I uploaded this add-on, and I'm really thankful for it, and I'm even more thankful for the people that have already donated to the cause over on Gumroad. So thank you so much. It's really going to help out, and the more that gets donated, the more time I can put into improving this add-on. I already plan to do a lot of improvements, and the more help that you give me, the more help I can give you with the Mannequin. So I wanted to make this video partially to say thank you, and also because a lot of people have been talking to me and asking me about the hows and whys of Mannequin compatibility and why my add-on works and the way it works. So when I did the original covering video for the release of the add-on, I didn't really go into too much detail about what's actually going on in the armature to make it compatible. So I'm going to do my best to try and explain that in more detail here. Now, the rule I've gone with is that the Mannequin must enter Blender and leave Blender the same. It mustn't change during the import and export process. So I've imported the default Mannequin from an FBX that's been exported from Unreal Engine without changing a single setting. So everything's been exported by the default settings and imported into Blender by the default settings. I have changed some export settings, but they don't affect the way the armature is. The armature itself stays the same throughout everything. All I've done is added a whole bunch of controls to the armature, enabled for it to be able to be manipulated in Blender. So let's dig into how this really works. So I briefly showed in the covering video for this these deform bones and these mechanism bones, and I pretty much just said these deform bones follow these mechanism bones are parented to the control bones. That's true, but it doesn't really explain why this works. So let's start by saying that the Mannequin isn't designed for animation in Blender at all. It's designed for animation in Maya. So it's not compatible with Blender's default primary bone axis of Y. So the primary bone axis is the way that the bone points. I think it's using the X-axis, but I don't really use Maya. I've tried it, I don't like it. I much prefer Blender. So I'm not 100% sure on that, but it's definitely not using the Y-axis as its primary bone direction. So that's why they're all pointing the wrong way. But this is how Unreal Engine wants to read the Mannequin. This is what makes it compatible. If we can animate these bones, even though they're pointing all over the place, then we can make animations that are compatible with the Mannequin without having to retarget them. So these are the deform bones. These are the only things that are actually getting exported to the FBX, because they have this bone setting down here, deform, which means they deform the mesh. These are the only bones that are deforming the mesh, and they're the only bones we want to export to an FBX. But we can't animate them like this. They're all pointing in funny directions. They're completely incompatible with most animation methods in Blender, such as inverse kinematics and a lot of copy rotations and stuff like that. So I needed to find a workaround. I needed to find a way around this. And my way of working around this was to duplicate them twice. So the first time I've duplicated them, I've created these mechanism bones here. These are exact copies, location and rotation. These are identical in edit mode, transform wise, to the deform bones. Now, the only thing that's different between these bones is the hierarchy. So I've got these bones here that I'm exporting. I cannot change their locations, I cannot change their rotations, and I cannot change their hierarchy. I can't touch anything at all about them in edit mode, or it's going to break compatibility with the Mannequin. This is where these mechanism bones come in. These mechanism bones are there to hold the location and rotation for the deform bones. They do not have their deform setting set to true, they have it set to false, so they won't get exported in the FBX. But they're still holding this location and rotation in edit mode. They're still holding the rest pose of the default bones that have come from the Mannequin. So I can tell these bones to copy their transforms in world space. So whatever the mechanism bones do, the deform bones will follow along with that. They'll do whatever the mechanism bones are told to do. What I can change about the mechanism bones that I couldn't change about the deform bones is their hierarchy. So I can parent these bones however I want and manipulate them that way. So this is the link. This is the way the link sort of goes. So I've got the deforming bones, the bones that we actually want to be getting into Unreal Engine. Then we've got these mechanism bones that hold their location and rotation and sort of almost override their parenting, because it doesn't matter how these bones are parented, they're always going to follow these bones. But it does matter how these bones are parented, because they've got to keep the hierarchy of the mannequin or they won't be compatible. So those are the mechanism bones, that's what they're for. So I can move the mechanism bones around, I can parent them however I want, but they still have the wrong locations and rotations. In edit mode, I still can't animate with these bones. What I can do with these bones is change their parenting. So the second set of duplicate bones is the control bones. All the yellow bones are duplicated from the deform bones, but the difference here is they've all been changed. They've all been snapped into position. They've all been snapped into position so that they can be animated in Blender. With these bones, I can change anything I want about them, but not their points of rotation. They must still keep the deform bones' original location for their head, but I can put the tailbone wherever I want in edit mode, and I can change their bone roll as well, which is also very useful for mirroring animation. So these deform bones, I'm going to keep going back over it so I know that I'm saying exactly what I mean, really get this across, because I've had real trouble trying to explain this. So the deform bones are what's getting exported, they're what we need. The mechanism bones override their parenting, but keep their locations and rotations in edit mode. And then these mechanism bones are then parented to their equivalent control bones. These equivalent control bones are then positioned correctly for animation in Blender, so they can be compatible with copy rotations. I can change their bone roll however I want, and they still have the same correct point of rotation, so we don't get anything offset when we start rotating these bones. So what happens when you're animating with this is these control bones, which are pointing the correct way, with their children of the mechanism bones. So when we rotate, let's use the head and neck for an example. When we rotate the control bone, its child is going to rotate with it because it's inheriting its rotation. So it's inheriting its rotation and it's moving with its parent. Because this bone is now moving with its parent, and the deform bone has a copy transforms constraint to the mechanism bone, it's also moving with the mechanism bone's parent, the neck bone in this case. So the deform bone is getting manipulated by the control bone indirectly, so that I can have these deform bones doing exactly what these control bones do, which gives me the freedom to change everything except the points of rotation. And you can't really mess around with the points of rotation on a mesh anyways. If you mess around with the points of rotation, it's not going to rotate in the right way, and it's not going to deform correctly. So I was never going to be able to change the points of rotation, but I can change pretty much everything else about these control bones. And that is how Mr. Mannequin here is compatible. He has entered Blender just as Unreal Engine wanted to export him, and just as Blender wanted to import him, and then he leaves Blender as he's expected to for Unreal Engine. So this is what Unreal Engine is expecting to get back, and this is what it gets back. So he enters without his rest pose being messed around with, and he leaves without his rest pose being messed around with. Nothing gets changed in edit mode. I did also mention that you shouldn't keyframe these bones. I think in another update I might even hide them. I might hide both of these bone layers, because people really shouldn't be messing with them. You mess with either of these two layers and the compatibility will be broken. It won't work. If you so much as move something by 0.1 in edit mode, it's going to give you skeletal import errors when you try and import anything to Unreal Engine with it. And if you keyframe it, it's no longer going to be following the control bones correctly, so you're not going to get the right animations. So that's how this works. So let's talk a little bit about the actual export process. So what I've got is a script. I've got a script for Mr Mannequin Tools that exports the FBX. So this doesn't just run an export FBX operator. It doesn't just fire the event to throw out an FBX. It actually does some scaling for me too, because I wanted to have the unit scale set to 1 for quite a lot of different reasons. The main one being for compatibility with Blender's physics, because anything under a unit scale of 1 is going to start throwing out physics errors when you try to bake the simulation. So if you try to create a cloth simulation at a scale lower than 1, it's not nearly as accurate than it is at 1 or higher. The higher this unit scale number, the more accurate things like cloth simulation and particle physics seem to be. So the larger the scale, the easier it seems to be for Blender to bake physics. So that's the main reason I've decided I really wanted this at unit scale of 1. Now the scale of this armature is probably about the only thing we can change once we've imported it without actually messing up the bones. See, the bone position staying the same in rest pose. So all I have to do is scale this up to the expected scale for Unreal Engine, and everything inside the armature is going to scale up with it. But animations do not scale up with it. So if I created an animation on Mr Mannequin here right now and I wanted to send it to Unreal Engine and I only scaled the armature up, the armature is going to have a height of 161 meters because we need to multiply it by 100 to make it compatible with Unreal Engine. So we'll have a height of 161 meters instead of 1 meter 61, 1 meter 57. I said the x-axis. So all of these numbers are going to be multiplied by 100, but the animation's locational keyframe data will not have been multiplied. So what this export script does is on export, it loops through every locational keyframe channel and multiplies it by 100 as well before it exports anything. So it scales the armature up by 100, that's pretty simple, and then it goes through every animation that we're trying to export and scales all of the location data for it to then fit to Unreal. That's why this export FBX button can take quite a while to process if you're exporting quite a lot of animations, because it does do quite a lot of work. It's a pretty performance intensive piece of script. It hasn't, like I said before, it hasn't crashed me before. It just hasn't crashed me. It seems to be working fine. Occasionally Blender will hang if I do lots of animations or anything like that, but the script is working very hard and it does a hell of a lot, going through every single keyframe, every single transform channel that ends with location. Let's just open the script for the FBX so I can quickly run over that quickly. So another thing it does is it prepares the action. So at the beginning of every action, it sets the frame start and frame end for that action, and then it goes into pose mode, unhides any hidden bones, selects all the bones, and clears all their transformations. It also, somewhere else in here, it actually does the layers too, so it turns all of the layers on and then turns them off again afterwards. Well, it used to. It doesn't actually turn them off again afterwards, because I wanted to go on to why you have to save before you export as well, because that's quite a big reason for performance for doing that. But first, let's talk about UE4 scale. So I was talking about looping through the animation. So this is the piece of script here that loops through the animation. It goes through each curve in the actions F curves if that F curve ends with location. So if it's a location keyframe, because rotation and scale are both relative to the bone. They don't need to be scaled with it. So it doesn't matter if your bone's 1 meter long or 10 meters long. If you rotate it by 90 degrees, it's going to rotate by 90 degrees at either end. Doesn't matter which way you've scaled it. And the scaling of the bones themselves is actually relative to the scale of the rig as well. Similarly with shape keys as well. Shape keys are also relative to the scale of the mesh, I found, which is why they go so easily, and I haven't had to do any scaling for them in here. So I've looped through all those F curves. For each key in the curve's keyframe points, if that curve data is even in the arm which is pose bones, because we might have an action which has other objects keyframed into it too, then we take that key and we multiply it by the given float value. So that comes through here at the top of the function, so that's going to be set to 100 when this happens. I used to use this to scale back. When I first was testing this, I'd scale the animation for export, scale the object for export, then once the exportation was done, I'd then roll back through everything and set it all back. Let's get this to the init where the operator for this is. So this is why it has to be saved. If the blend has been saved, even if it's only been saved once, that's fine. Then we save the file before we start the export process, and then once we finish the export process, everything's all scaled up to Unreal Engine size, so everything's way too big by 100 times. Once we've done all the export, instead of iterating back through and setting everything back to the way it was, it's actually much more performance friendly to just reload the file from the state that it got saved at before we exported anything. I think that's just about everything I wanted to cover with this. I don't want it to be a long video. I just wanted to really go through and sort of explain a bit better about why this is compatible where just snapping the bones into place isn't. It's all about the rotation of the deform bones. It's all about the bones coming into Blender and going out of Blender with an identical rest pose. The scaling can be changed because it's proportionate. So they've come into Blender as they're supposed to be. I've then set their scale to 1, and then they're leaving Blender back at their scale that they came in at, which is 100 times what it is here. So that's why this works. And just at the end of this video, I want to say that I'm really pleased because I've managed to get animations into Blender with a script, and I can get them onto these control bones, not onto the deform bones or anything like that. I can get animations from the mannequin into Blender and convert it onto this armature here. I was really pleased with this. It's much more performance friendly than I thought it was going to be. I thought it was going to be a real heavy load and there'd be lots of waiting around for things to kick in, but it's really not as bad as I expected. And I'm also having a really interesting conversation with someone about exporting the mannequin from Blender to Unreal Engine using Gltf files, if you know what they are. So instead of fbx.gltf, and I think there's a lot of promise there because Gltf seems to be much better supported by Blender than FBXs are, and the person I was talking to already has a plugin that allows import and export of skeletal meshes using Gltf instead of FBX. So I'm going to put a link to their video down below, the video I saw that really started me talking to him about it, and hopefully in the future I'm going to be able to provide more compatibility than just FBXs. Hopefully there's going to be more buttons here where you can export your characters into different formats. That's probably going to take quite a while to happen, but that's definitely in the works, and I think it could be a really positive thing for Blender to Unreal Engine workflow. So thank you for watching. Thanks again for all the positive feedback. I'm totally overwhelmed by it, and stay tuned for plenty more. I'm going to add so much more to this mannequin. I'm going to add entire new rigs. I'm going to add entire new meshes. I really want to make something really great, make something really useful for a lot of people. I hope you have a great day.